Let us look at arithmetic progression in a little bit more detail. Now, in the previous session, we have already seen what it is actually, but let's refresh our memory. It is a list of numbers in which each term is obtained by adding or subtracting a fixed number to and from the preceding term, except the first term. Because remember, in the previous session, I mentioned that the common difference can be positive or negative. So the fixed number is called the common difference, and usually we use D to represent it. Now, given an arithmetic progression A1, A2, A3, A4 and so on, where the subscripts specify the position of the terms and n is in the set of natural numbers, then since we have a common difference, that means A3 minus A2 is equal to D. A4 minus A3 is equal to D. That means in general we can say AN minus A sub n minus 1 is equal to D. We can write the sequence in the following manner as well. We can start with A1, that is our first term. Second term will become, because of the common difference, A1 plus D. Third term will become A1 plus D plus D. Fourth term, A1 plus D plus D plus D, and so on. Simplifying this a little bit, we get A1 first term, A1 plus D second term, A1 plus 2D third term, A1 plus 3D the fourth term, and so on. So in general, we can say the nth term A sub n is equal to A1 plus n minus 1 times D. So how did this n minus 1 come? Because if you notice here, for the first term, we don't require the common difference. There is no D here. In the second term, we have 1D. In the third term, we have 2 Ds. In the fourth term, we have 3 Ds. That means we have 1 less than the position. So that is why n minus 1 D. So the progression can be finite or infinite. We have already seen this before. If finite, there will be the last term. A sub n is equal to L in the sequence. So we would have A1, A2, A3 dot 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 A sub n minus 1, A sub n, which is equal to L. If it is infinite, then A sub n would be some intermediate term and the sequence would keep going. So that we would write it something like this. A1, A2, A3, A4 dot 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 AN, A sub n plus 1, A sub n plus 2 dot dot dot. Now, if you want to show a previous term to A sub n, we would say A sub n minus 1, A sub n minus 2. So now, if we are given two non-adjacent terms in an AP, and also the position of these terms, we can find the common difference. Let's say we are given this dash 1 by 2 dash 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 6.5, and we are told that this is in AP. So here second term A sub 2 is equal to half, and sixth term 1, 2, 3, 4, 5, sixth term, that is A sub 6 is equal to 6.5. This is what we are given. Now A sub 6 minus A sub 2 is equal to 4 times D. How did we arrive at this? Because remember here, second term A sub 2 is equal to A1 plus 2 minus 1 D, that is 1D. And in case of A sub 6, it is equal to A1 plus 6 minus 1d, that is 5. So 5 minus 1 d's will give us 4d. So a sub 6 minus a sub 2 is equal to 4 times d, which means 6.5 minus half is equal to 4d. And we arrive at d is equal to 1.5. So common difference we have found, which is what we had to find. But suppose we are also asked to find the 100th term. Now in that case, we use this formula, but for that we require a sub 1. That is the first term we need. So let's figure out the first term. So a2 we already know. So a2 is equal to a1 plus 2 minus 1d. So a2 is half, equal to a1 plus 1.5. 2 minus 1 is 1, d is 1.5, which implies a sub 1 is equal to minus 1. So now we have found the first term. So that means the 100th term, a sub 100, is equal to a sub 1, that is minus 1, plus 100 minus 1 times 1.5. And if we evaluate that, we get a sub 100 is equal to 147.5. Now, summarizing what we learned now, in an AP, A1, A2, A3, dot, 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 AN, the common difference is the difference between the two adjacent terms, that is a sub n plus 1 minus an. Now, if we don't have adjacent terms, but we do have non-adjacent terms, then the common difference d is equal to the pth term minus qth term divided by p minus q. And nth term, a sub n, is equal to a1 plus n minus 1 times d, where n is in the set of natural numbers, and this we can use to find the nth term. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.